It's by controlling pressure. Okay? Because it's at saturated steam because of the nature of the way a steam trap works, but by controlling pressure is how we can control temperature in that sterilization cycle. During the actual operation of the reactor, it's entirely different. These are actually set up with a recirculation loop where the outside of the jacket on these units, if you look at them very carefully, clearly they have a stainless steel jacket that has been put on the outside of it. That is where I need to control the temperature. Okay? And so I need to then have a liquid circulation loop, and that liquid circulation loop will loop through the reactor, and it'll come out, and if the temperature is too cold, then I do heat exchange with steam. And there's different versions. There's a shell and tube on that one. There's a plate and frame heat exchanger on this one. And then if I'm too hot, what do? I just simply open, it turns out, I open the loop out of the loop to drain based on a solenoid. And it always has a water supply line on it that will bring cold water into the system. And so by me opening the outlet to the system, it'll bring in cold water in return for that. And that's how you accomplish temperature control on the unit. Heat it with heat exchange if it's cold, and then allow a little cold water in if you have gone on the other side of that. The other aspect of these is that on the bottom of these units, you'll notice that there's a lot of these ports, and the ports are very, very similar. In fact, they're referred to affectionately as Ingold ports because somebody decided what it should look like. Who do you think it was? Ingold. Okay. And Ingold was a dominant manufacturer of probes for pH, dissolved oxygen, and so forth. And so they had essentially the industry standard for a 25 millimeter port. Okay? And so if you want to have a probe, you just, for the most part, for steam sterilizable equipment, they all are the same. Okay? In these, we call them old school reactors, not the disposables and so forth. Okay? And so then that's what these ports are on the bottom. They're in the liquid phase of this thing. And that's where you would put your pH probe. That's where you put your dissolved oxygen probe and so forth. And in fact, if you take a look on the bottom side here, they'll see that these are actually transducers. There should be some on the back side of that unit there. And so in a way, you see on the back side of that unit there's two little canisters. Those are just the transducers. But what this does is it gives a little bit of uniformity, right? If you want to be a manufacturer of a new probe, you just need to make it go through a 25 millimeter Ingold port and talk to that transducer there, and then anything you get, you can slap it in there and it'll talk through that system to the controller. And that's what the computer is in here, is that basically this is really, honestly, this is just a monitor. This does not control the fermenter. The guts of the controller is actually inside the boxes here, and it's just talking to it so you can actually see a screen. Nobody trusts a damn PC to run their fermenter. So let's see, other bits and pieces that I wanted to make sure that I went to. Okay, so quiz time. Well, what is the little black box here? The little black boxes. You don't remember. How about you? You don't remember either. Pressure controller. This is just simply, all it is controlling air pressure. The computer's telling it to take the 100 psi supply line pressure and adjust it to whatever piece. So every piece of equipment that has a air pressure regulated valve on it, and there are numerous of them in here, okay, that air pressure regulated valve then is set up based on the pressure coming from the computer telling it what to get from over here. One of my favorite unusual things that you have in here was what I saw the tall guy in the back here looking at earlier, and it was this really sophisticated thingy here, which is It's a metal rod. Okay, okay, and so it's a metal rod. There's no electrical wires in it. Okay, simple question, except for you. Okay, okay, because I think I already told you what this is. Maybe, maybe not. Okay, we'll come to you later. In the blue. Yeah, you, president of AICHE, right? So what do you think this thing is?
Health agitation.
What?
To help with agitation.
Okay, no. Okay, okay. So there are inside this, there are 4 baffles, roughly 1/12 of the diameter of the tank, that give rise to the mixing so that you can take rotary motion and turn that into axial motion, and that's how the mixing. We'll talk about the design of the tank guts inside there. This isn't going to provide much mixing. Not a bad guess, but yeah, it's a pretty bad guess. Okay, anyone else? Katie.
Let me see. Does it have a hole?
No hole.
Oh, no, I don't know
Okay. What's that? It's a continuity. And so how does a continuity, what is a continuity probe for? No. That's right. This is something for as simple as level control. Okay? And so if I put this inside the tank here, and if you look very carefully, it has a gasket. This gasket is made out of a non-conducting material. And if you're very careful, you can see that at least on the top of this, it's actually plastic coated. And then once you get down to here, it's no longer plastic coated. So there is no electrical contact with this at the top where it actually goes through the swage lock fitting. Okay? And so you can imagine that what you can do is if I just simply put a little alligator clip on here, and I measure the resistance between there and any other piece of this tank, okay, the resistance will be infinite until the liquid makes contact with it. Once the liquid makes contact with it, then it would actually give you 0 resistance between the two, and you could use that to know level heights. So when I was talking about how we would do on an airlift for the fermenter, which if we get permission to find somebody to grow an airlift, probably what we would do is come up with a very, very simple circuit to make up for evaporative water loss by putting a continuity probe inside there, and every time the water goes down below that level, that'll actually activate a pump. The pump will turn on until it comes back up, and then the continuity, it gives you simple plus minus logic of on-off control for level. Now it turns out that's not the dominant use of what it is used for in this tank. It's used for something else. Anyone want to take a guess? Remember what's happening. And what is the gas flow rate in here? 300 liters a minute. See how much you guys are learning so fast here? 300 liters a minute. So what is my main concern if I'm blowing 300 liters a minute inside this thing? What? Well, nah, 300, you know, it's got holes all over the place. So, and remember that the supply line pressure of this thing is no more than 100 psi. In fact, it's a lot less than that. In this case, it's probably running about 15 psi. So there's no way that we're going to have a problem with blowing up the tank with the air pressure that I have that little crappy compressor out there. Okay? Instead, it's going to have to be something else.
Foaming?
Foaming. You know, you're going to be blowing air in there, and your whole idea of getting high mass transfer is to use the impeller to break it up to make little teeny tiny bubbles, and then at 300 liters a minute, that little tiny bubbles have to condense and make it out the system. You okay there?
Yeah.
Okay. So, if it blows past the condenser, you're SOL, right? Because then it's going to go through these little tiny tubes, and the foam is going to make it out to our microbial filter, blind the filter, and our pressure regulator is going to be lost now because we no longer have restrictive flow. We have a blinded 0.2 micron filter. And so what you would do is that this can be actually just set up so that it's looking for foam. And when the foam level actually gets up to there and touches that probe, then you now know that you need to add antifoam. And so that'll be set up to another pump. The pump will actually kick Antifoam into the system to knock the foam down.
This might be a stupid question, but where do you actually take out your products?
Good question. Okay, you take it out at the dropout valve. Okay, so way down on the bottom of the tank here, okay, is a very, okay, you can look at it when you get to these things later, but there's a valve down there that is, it's a ball valve. And for the those of you that know what different kinds of valves are, I think I could probably find one over there. I'll bring one to class at some point. A ball valve is such that it's a round ball that has a hole in the middle. When it's open, it's wide open and you can't even tell there's a valve there. Therefore, its K value in terms of pressure drop is equal to 1. Okay, so it has no contribution other than the normal friction that you would get through a regular. So the other thing is they're really nice to clean. Okay, that one down in the bottom there is a giant ball valve so that you can really open that sucker up and get stuff out. To give you an idea, on the mammalian cell reactor on the far side, we had trouble with the ball valve when we originally set it up in 1990, and it was being run with very high densities of like microcarriers, and then they would like make a filter and clog the thing in there. So we had to replace it, and it cost us $7,000 for the ball valve replacement on there, the stainless steel ball valve. Okay, so it kind of gives you an idea. This is not a cheap sort of business for dealing with that, but it's called a dropout valve because it's such a big hole in there that you can kind of put that. And if you were going to take this, for instance, and run this fermenter, you'll now have, you know, the 250, 300 liters of yeast or E. coli or something, and you'll want to run it downstream to a centrifuge that I'll talk about later in the semester downstream there. And so what you do is you take a process line from there at the bottom of the dropout, and then you put it over to here onto the header, and that actually, somebody put a little thingy in there. It's product transferred to the room where centrifugation is, and then you take that and you open that up. You pressurize and kill the outlet to the valve here, put a little pressure on it, and you can run this whole tank downstream for downstream processing. You don't have to roll the tank or carry buckets of stuff through the facility. Okay. Let's see. I'm trying to think of other things that, well, I mean, I can't cover even a fraction of this stuff. But at least it starts to give you an idea of what I'm talking about. A skid, pressure. We'll talk about a little bit about control, cascade control, and so forth later. This is what we're referring to. It's a real thing, not a box with an impeller drawn in it. Any other questions about this?
How do you clean the parts? Do you stick them in an autoclave?
Remember, it is an autoclave, so that's the neat thing about it. What I can do is after I product transfer in that, I just open my process water line, which is purified water. I run the thing full and then I cook it. And that'll at least give me the ability to kill everything that's in the tank itself. The other thing is that there are some things in here that are so-called CIP. What does CIP stand for? Clean in place. And so it's kind of like a fancy shower head. And you take the fancy hot shower head and you put it down through in here with the actual sterilization filters on it there. And then you put the process flow line on it and it spins inside there. So cleaning these units is a little bit of an art. And the other thing that you do is there's lots of big brushes. And you start, and you really need to go through the process of cleaning it. So killing it, that's one thing. It's easy. It's an autoclave. Cleaning it and getting the rest of the stuff out of there, that's another problem entirely. Let's see. I guess that covers pretty much what I had wanted to cover. From here, you can kill this. We don't need to have it anymore. What's going to happen is I'm going to set up a schedule, and the schedule is probably going to start